So hello ma'am, welcome to my presentation. So my name is FRANZ Brillante. So let's start. So for my research one, the title is a knowledge-based intelligent electronic commerce system for selling agricultural products. So the author is Wu Wen. The year published 2007. The publication Elsevier and the algorithm used in this study is backpropagation algorithm. So basically, this is a e-commerce system for selling products with AI. So the AI news are the rule based and the model based. So basically the knowledge based and the neural network. Okay, so this e-commerce provides agricultural product sales, financial analysis, and sales forecasting, and also provides solutions or actions based on the results of rule-based reasoning. Okay, so basically this is just an e-commerce system for selling agricultural products with interface or user-friendly interface. So basically, this is connected to our subject in IS because this study talks about the two AI, which is the rule-based and the model-based AIs. So let's go to the second slide. And for the methods, so this study employs case-based and rule-based in a model. So the problem here is the inaccurate gathering of data for the food sales and other buy trends. Okay, so the strength here is the researcher created a business to consumer electronic e-commerce system for agriculture products with AI. So this AI can really help the system to easily gather the data and to display the data with with solutions for the future use. And the weakness here is the knowledge-based intelligent commerce system was developed for research purposes only. So it might not able to maintain the accuracy or the efficiency of the data and the system as well. The results are, as you can see here, these are the images of the user-friendly interface of the system. So you can see here the login menu and other stuff. Let's go to the graphs. Okay, as you can see here, the graphs. The first graph talks about the comparison between actual and desired value, and the second graph is the forecasting values for the next 3 years. As you can see here, these are the results. So as you can see here in this image, the AAN successfully forecast the grapes for the next 3 years. So it forecasts the value of the grape for the next 3 years and the value of the current value and the desired or the goal value for the grapes, as you can see here in the first graph. Let's go to the second graph, the pie graph. As you can see here, the analysis of sales percentage. This is the graph when or which product is the most high in profit or the most people buy. So for example, the watermelon has the high percent with 18.5%. So meaning the people usually buy watermelon. So the users can really so this information will really help the user or the managers of this system. So let's proceed to the next graph. This is the knowledge and reasoning and decision making. So because of the rule-based AI, it can gather and perform and provide the data for performance achievement. So the first the first graph rather, I'm very sorry, talks about the comparison between goal and actual value, and the second graph talks about the comparison between net profit ratio of that specific store. So let's go to the conclusion part. So the conclusion part is that the researcher provide or design an efficient intelligent e-system with GPS and EMAP, and as you can see in the results, the system provides the data about the financial profits, about the sales trends, and also it provides solutions or alternatives for the near future. As you can see, the system is really working with those two AI, which is the rule-based and the case-based AIs. So let's go to the research number 2. So my title in the research number 2 is Applying Artificial Intelligence Modeling to Optimize Green Roof Irrigation. The authors are Chang and Jim. The year published is 2016, the publication is Elsevier Science, and the algorithm uses the genetic algorithm. So in this study, again, it's pretty interesting because it employs two different AI, which is the neural network and the fuzzy logic. So this study talks about the green roof irrigation with AI modeling. So these two AI will gather the data using the weather data to simulate the soil moisture changes to develop an optimal irrigation system or strategy. So the artificial neural network is trained to predict the soil and moisture based on 4 daily weather variables, while the fuzzy neural network AI is applied to determine the irrigation time and the watering volume for the irrigation system. So let's go to the next slide. So let's go first to the strength. So the researchers applied two different artificial intelligences to enhance the green roof irrigation. So these two AI will help, or like it will gather the data and it will provide the needed data to be able to have a like to be able to mimic the behavior of the human in doing the irrigation system. So the weakness here is the weather data is the basis. The four weather data are the basis of the AI, of the two AI. So if the weather or the climate is rapidly changing because of global warming and other factors, these changes might really affect the prediction and the accuracy of the system in the long run. As you can see here, this is the flowchart of the modeling methodology. As you can see here, the measured soil and the real time is the data, the free data. So the ANN, or the artificial neural network, will gather these two data and it will go to the simulated soil moisture, and another data for the neural fuzzy system will gather these two data and it will go to the irrigation time. It will do the irrigation time and watering volume based on the data the neural fuzzy system gathered. As you can see here in the results, these are the graphs of the results. Let's go to the first four graphs. This is the air temperature graph results, and the second is the solar radiation graph, the relative humidity graph, and lastly the wind speed graph. So these results or these graphs are happened during the experimental period of the study. As you can see here, it gathers the data on how or what are the temperature, the radiation, the wind speed, and other excuse me, other weather variable. And again, this is for the pan evaporation to be gathered by the neural fuzzy logic or neural fuzzy system. And then again, this is the flowchart. And these are the simulated and measured soil moisture in the course of training. So this is the graph for the simulated and measured soil moisture gathered by the ANN, or the artificial neural network. And this is for the percentage error between the simulated and measured soil moisture in the course of the experimentation. So let's go to the next slide. Okay, so for me, the conclusion of this study adopted AI algorithms to mimic the behaviors of human brain in making irrigation decision. So the real-time weather data was used to predict the soil moisture, and with the aid of AI, the critical irrigation needs of green roofs, particularly on dry and sunny days with high evaporation rate, could be satisfactorily optimized. So as you can see in the results, the system is perfectly working with the two employed AIs, which are the fuzzy logic and the neural network. And that's it. So let's go to the research number 3. So my title for the research number 3 is the time series sales forecasting for short shelf life food products based on artificial neural networks and evolutionary. So the authors are Philip Duganis, Alex Alexandronis, Panagiotis Patrino, Saram Lambos, Sarimves. The year published is 2007. The publication is Elsevier Science, and the algorithm used is back propagation algorithm. So basically, again, connected pa rin ito sa ating subject na IS because it talks about the AI, which is artificial neural networks. So this research study also presented the complete framework that can be used for developing nonlinear time series sales forecasting models. Again, this study employs the neural networks for time series sales forecasting. Okay, so the methods used in this is, so the problem is there is a strong competition in the food business industry. So this study is all about the time series sales forecasting for short shelf life food products such as milk or any other dairy products. The researchers use and employs the artificial intelligence with genetic algorithms to their system to calculate and monitor the sales of data of fresh milk provided by the company in their experimentation period. So this study employs again two algorithms. First, the genetic algorithm, and the second algorithm is the GARVF algorithm. The GARVF algorithm provides a complete framework for building time series models based on the available data, while the genetic algorithm is machine learning procedure which derive their behavior from the process of evolution in nature and are used to solve complicated optimization problems within the system. So let's go for the next slide. So I'm going to talk about the first the strength and the weakness of this study. So the strength is by applying an AI neural networks with genetic algorithm and GARVF algorithm in the system can total the data or like gather the data and provide the sale forecasting based on the gathered data of the two algorithms and the AI, which is the neural networks, and the sale forecasting for short shelf life. Okay, so it will provide or forecast the sale for the short shelf life food products such as milk and other dairy products. So basically, this is just a framework. This is a framework for the AI, something like that. Okay, so the weakness is since the prices and other factors in food and business industries are fluctuating through the years, it might really affect the accuracy of the sales forecasting of the system. Lastly, the other information such as the other are not provided in the system. Okay, so for the results, as you can see here, I will show you the graph provided by this study. First, this is the first graph or the topology of the RBF neural network topology. Again, this is for the RBF algorithm or for the network. RBF network architecture rather. I'm very sorry about that. Again, this is the graph for the forecast error for different time series methodology. So each variable here, like the linear AR, the Holt Winters, the linear AR, are the methodologies for different time series. And again, in the third graph of this study is the actual sales data and the RVF model predictions in the or within the system. So that's the results. That are the results. These are the results of the study. So again, for the conclusion, this research study also presented the complete framework that can be used for developing nonlinear time series sales forecasting models. This study also applied the neural network artificial intelligence in their system with genetic algorithm again and the GARVF algorithm. So again, I will explain to you what is the GARVF algorithm. It provides a complete framework for building time series models with the available data, while the genetic is for the machine learning procedures. As you can see in the results, the system is perfectly fine, accompanied with the two algorithms and the AI. So the system accurately provide the data of the short shelf life products, which is the milk. So that's it for the presentation. Thank you and God bless more.